Hello, everybody. This is Bert Dixon here presenting on the second half of section 8.3, and that is on the Orthocenter, which is our last center. We have 4 special centers for every triangle, and so the Orthocenter is the intersection of the altitudes, and an altitude of a triangle is defined right up here. An altitude this is on page 387 in your books. An altitude is a perpendicular segment from a vertex to the line containing the opposite side. So that the way that they wrote that is a little bit confusing. If you draw a line from any vertex, it needs to be perpendicular to the opposite side. Okay, so I'll show. We'll do some just some sketches. So what you're going to need is a couple pieces of paper, and you're going to need eventually you're going to need your geometry tools, so your compass and a straight edge. Okay, so as soon as you have those, let's just talk in general about what an altitude looks like. So I'm not even going to use any tools right now. I'm just going to draw a sketch. Okay, so I've got a scalene acute triangle here, and an altitude is a line segment that goes from a vertex to the opposite side, and it's perpendicular to the opposite side. So I always like to use the analogy of dropping a rock. If this is the ground, and this is like a mountain, and you have somebody standing up here at the top of the mountain, and people standing down here on the ground, okay, when you drop a rock from this vertex, we'll call this Vertex A, when you drop a rock from Vertex A rock always falls perpendicular to the horizon, so that would fall straight down here. So that is one of our altitudes. Okay, so that green segment is an altitude of the triangle. Okay, it's a segment that goes through a vertex and is perpendicular to the opposite side because it's making a right angle right here. Okay, now we also have an altitude from Vertex B and an altitude from Vertex C. So there's a couple ways to get those, and one way is to use an index card or something like that that you can slide along the side. So when we draw our altitude from B, it needs to go perpendicular to side AC. So that's why I'm sliding the card along AC, and I'm going to continue sliding the card along AC. Watch this edge right here. Okay, I'm going to slide this card along AC until it goes through point B. Point B is right there, and so there's my altitude. Okay, because that's forcing it. The card, the purpose of the index card is the corner of my index card is a right angle. And so that's forcing that angle to be a right angle. And so that's Vertex B. Okay, so that's one way to get that altitude. If I'm just doing a sketch, then I could also turn my paper and drop another rock. So if I turn my paper so that AC is the horizon, then people would be standing here on the ground. And if you're up here at Vertex B and you drop a rock, it's always going to fall straight down perpendicular to the ground. So that has to form a right angle. Okay, and then we could do the same thing from Vertex C. I could turn my paper so that AB is perpendicular, or so AB is the horizon. People would be standing on the ground here, and if you dropped a rock from C, it would fall straight to the ground at a right angle. And again, you could do the same thing with an index card. If we slide an index card alongside AB, until it goes through C, then that would help us draw the altitude more precisely. Looks like I got it in a pretty good spot. And if you do them all three accurately, I'll put them all in green. So there's another altitude and the other altitude from B to CA look like this. And notice that they all three intersect, so they're concurrent, just like our other special centers. All three altitudes should be concurrent. Okay, so that's how you sketch them. One thing I want you to notice is that if I sketch an obtuse triangle, let's say we have an obtuse triangle like this, obtuse angle here. Notice that when I drop a rock, if I'm standing up here, if this is A, B, C, if BC is the horizon, I'm going to extend that horizon a little bit. If I drop a rock from A, it has to fall perpendicular to the ground. And again, I can use this card to help with that. If I slide it along here until it touches A, that tells me where my altitude is. And that makes sense because if I dropped a rock from A, it would fall straight to the ground like that. So in this case, one of our altitudes is outside of the original triangle. Okay, now let's do the altitude from C. So if I turn my paper and I drop a rock from C, it would land like that. Or if I slide the card along the base until it goes through point C, we can get a nice crisp right angle there. Okay, so there's another altitude. It goes through C and is perpendicular to AB. And then the third altitude would go through point B. So we want an altitude from point B. And again, if we want to drop a rock, it might help if we extend this side in both directions so we can see if that's the ground level, I would have people standing on the ground like this. Okay, if I dropped a rock from point B, it would fall straight to the ground, which looks like it might just go off the corner of my paper. Also, if I slide this card along AC, that'll force me to make a right angle here, and that looks good. So that altitude is actually off of my page a little bit. So there's most of it, okay, and that forms a right angle right there. Okay, now we said that, and when we did this first one, we said that all three of the altitudes intersect, that they're concurrent. But these three don't look like they are touching each other unless I extend them. Okay, so I'm going to put another piece of paper under here to make this a little bit longer. And now if I extend those three green lines, they will all, if I did them accurately, I just sketched them, remember, so they're not totally accurate, but they would all three intersect out here. And that would be the orthocenter. Okay, so the orthocenter is the intersection of the three altitudes. And then we'll construct them in just a minute with compass and straight edge. Okay, now there's not really any useful significance to the orthocenter. We do it just, the only reason why we're spending time on it is because if we're studying the different centers of a triangle, we might as well include the orthocenter, but it doesn't have any practical applications. Like the purpose of the circumcenter is that you can find a location that's equidistant from 3 points. The purpose of the incenter is that you can find a location that's equidistant from the 3 sides, or 3 lines. And the centroid, the significance of the centroid is that it is the center of gravity. So all three of those have some usefulness. The orthocenter, there's not really any practical applications of why we would ever need to know the orthocenter. So that's one that we just throw in there because it's the fourth type of point of concurrency. Okay, so we're going to now do some compass and straight edge work to find the orthocenter. So this time, make sure you have an acute triangle. Make sure all three of your angles are acute. So try to draw a scalene acute triangle. Okay, so I have a scalene acute triangle. All three sides are different. All three angles are acute. Okay, so to construct the altitude from vertex A, I'll label it ABC. So to construct the altitude from A, what I'm going to do is I'm going to put the compass at point A, and I'm going to open up my compass so that it extends beyond line BC. Now, one thing I should do before I get started is make line BC as long as possible. So I'm going to run it from side to side until it goes off the page. Okay, so I extended line BC, and now from point A, I'm going to swing an arc that intersects BC twice. So that gives me those two intersection points. I'll call that P and Q. Okay, now what I'm going to do is construct the perpendicular bisector of PQ. So if I do the perpendicular bisector of PQ, it should go right through point A. Okay, so there's my altitude. Now I'm going to repeat that process for the other points. So now if I'm doing an altitude from point B, I need it to be perpendicular to AC. And so I'm going to open up my compass. First, I'm going to extend this side. I don't really have much room on my paper to go too much further, but just in case I need it, I'll extend side AC as far as I can. Okay, and now I need an arc that intersects AC twice. So I open up my compass, and I'm going to open it so it goes a little bit past AC. And there's my arc that touches AC twice, right there and right there. So I'm again going to call those P and Q. And now what I do is I construct the perpendicular bisector of PQ. And then draw the line that goes through those, and it should also pass right through B. So there's the altitude that goes through point B. Notice that it's forming a right angle right there. This one formed a right angle there. And then the last one, the altitude through C. So across from vertex C is side AB. So I'm going to extend side AB as far as I can. And then I'm going to swing an arc from C that crosses AB twice. Okay, so that arc crossed AB there and there. So I'm calling those P and Q. And now I'm going to do the perpendicular bisector of PQ. And if I did everything right, it should pass right through point C. So there's my third altitude. Now, this may happen to you as well. These they didn't come out concurrent. They're supposed to. It's because if I had a tiny bit of error anywhere on any of these points that I placed or any of the lines that I drew, one or maybe all of them are off by a little bit. Okay, so these are supposed to be concurrent, and so I'll just make one big dot there. But again, having a sharp pencil and working as large as you can, will improve your precision on that. But these three lines are supposed to be concurrent, and mine were off by a little bit, but they're pretty close. And so those are 3 altitudes, and that makes that the orthocenter. Okay, so this time for practice, I'd like you to make an obtuse angle, an obtuse triangle, and go ahead and construct all 3 altitudes and see if they are concurrent. They should be. See if you can be accurate enough to make them concurrent. Okay, so I have an obtuse angle up at the top, and I'll go ahead and do this. You can pause your video and try it on your own, and then if you get stuck, you can turn your video back on and watch this. And then we also have some book work to do right after this, so don't close your video down just yet. Okay, so from Vertex A, I'm going to swing an arc that crosses the opposite side twice. And then that gives me P and Q. And then I do the perpendicular bisector of PQ. So there's an altitude from A. To do the altitude from B, I'm going to extend side AC a little bit. And then I'll make an arc that crosses AC twice. That gives me P and Q. And now I'll do the perpendicular bisector of PQ. That should go right through point B. And then I'll do the altitude from C. First, I'm going to extend side AB, which is the side across from it. So that when I do the arc from C, it'll intersect twice. So that's why we label these P and Q, so that we can focus our eyes on what 2 points we're finding the perpendicular bisector of. And so now the perpendicular bisector of PQ is going to be formed by those two arcs. And if we did everything right, that should go right through point C. Pretty close. Okay, and if I extend this one a little bit further, they did turn out to be concurrent in this case. So a little better than the last time. All right, so all three of my blue segments are the altitudes, and the orthocenter is outside of the original triangle. Okay, notice the original triangle here. I'll do it in a different color. The original triangle is here in red. And so the orthocenter is outside of that triangle. Okay, so now we'll go back to the book. Okay, and so in the book we have on page 387, again, we have those definitions for altitude and orthocenter. And what we're going to do now is we're going to do the same thing, but we're going to do it on a coordinate grid using what we know about slopes and how to make perpendicular lines on a coordinate grid. Okay, so for this example, to construct the orthocenter, this altitude was very easy to get because it's easy when you have a when this side is horizontal, we know that the perpendicular line is going to be vertical. So we're just looking for a vertical line that goes through 2, 6. So that blue line is one of the altitudes. Now to do the altitude from point O, we needed to make sure it was perpendicular to this. This side has a slope of -1. So to be perpendicular to that, remember perpendicular lines have an opposite reciprocal slope. So if you take the slope of -1/1 and flip it, the perpendicular slope, if you flip it and change the sign, is going to be +1/1, which is 1. So if we draw a line that goes through point O with a slope of 1, we'd go up 1/1, up 1/1, up 1/1, up 1/1. It passes right through that point right there, and so that's how they got this altitude. We could do the third altitude, but it's not necessary because if we have two accurate altitudes, where they intersect is going to be the orthocenter. So it's not necessary to do all three. We can see that our orthocenter is at the point 2, 2. Okay, so let's do another one together. So this one, since this side is vertical, the altitude from A is going to be perpendicular to that, which is going to be horizontal. So there is the altitude from A. Okay, now to do the altitude from vertex C, we need to pay attention to this side opposite. This side has a slope of 1. So if I start at point C and I make a slope of -1, that would be up 1, backwards 1, up 1, backwards 1. That makes a perpendicular line, and so that is our other altitude. And these two altitudes are going to intersect if I make them both longer. This first altitude, I'm going to make it longer. And this altitude, I'm going to make it longer, continuing with a slope of -1 until they meet. There is our orthocenter. And that is at 9, -1 are the coordinates. Okay, so we're able to construct altitudes on a coordinate grid just by using slopes. Okay, go ahead and try, just number 13 would be fine. Go ahead and plot the points for number 13 and pause your video, try number 13, see if you can find the Orthocenter, and then press play when you're ready to check your solution. Okay, so for this example, I already have the triangle drawn. An easy altitude to draw is the one from point Q, because the side opposite is vertical, so that means the altitude is going to be horizontal. So there is the altitude from Q to RS. Then notice that if we wanted the altitude from S, the side across from it has a slope of 2. We're going up 2 over 1, up 2 over 1, up 2 over 1. And so that has a slope of 2. And so if we want to be perpendicular to that and go through point S, it needs to have a slope of -1/2. And so if I go up 1 and backward 2, up 1 and backward 2, up 1 and backward 2, this is the altitude to point S. Now remember, it's okay for an altitude to be outside of the triangle. This one is. And if we want to find the orthocenter, we need the intersection of those two red lines. And so I'm going to extend this one. And then I'm going to extend this one, continuing to go up 1 and over 2, up 1 and over 2, up 1 and over 2. And we see that they do intersect here at the orthocenter, which is at -2, -3. And that is it for today's lesson. You guys have a great day.